Good evening, great scientists, junior doctors, engineers, surveyors, and professors of different areas in sciences. This evening, we want to examine 2024 West African Senior Secondary Certificate Examination, Physics Practical, trial question number 3, that is on electricity. This is the circuit diagram of the question. This is the resistance box. This is the resistance box. This is the galvanometer. This is the galvanometer. This is the unknown resistance. This is meter bridge. This is meter bridge. This is the cell. This is the key. And these are the connecting wires from the unknown resistance to the meter bridge, from meter bridge to the key, from key to the cell, from cell to the left side of meter bridge to the resistance box, then from resistance box to the negative side of galvanometer, then to the positive side of galvanometer connected with the jockey. You are provided with meter bridge, a cell of EMF E, galvanometer, key, one standard resistor R is equal to 1 ohm, and 7 connecting wires and other necessary materials. 1. Connect the circuit as shown in the diagram above. 2. For value of R is equal to 1.0 ohm, connect the circuit and locate the balance point Y is equal to L on the wire AB, where galvanometer deflection is equal to 0. Read and record value L and evaluate L inverse, R inverse, and 1 over L. 3. Repeat the procedure for values of R is equal to vertical axis, so we are going to make use of 0.2 centimeter to represent 10 small square for plotting this graph. So we are going to start here. 0. This is 1.2, 1.0, 0.8, 0.6, 0.4, 0.2, 0, minus 0.2, minus 0.4, minus 0.6, minus 0.8, minus 1.0. So the same thing on the x-axis, horizontal axis. We are going to use 0.2 centimeter to represent 10 small square. So draw the line. Zero point 4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, 2.0, 100 over L, centimeter raised to power minus 1 as a unit. Unit of this is ohm raised to power minus 1. Now we want to start plotting the graph. When R inverse is equal to 1.0, 100 over L is 1.538. 1.0, 1.54. As I told you earlier on, we are going to plot to 2 decimal places. So this one will be 1.00 against 1.54. We approximate 8 to 1 and add it to this one. We approximate 9 to 1 and add it to 2, making 1.43. This one is not up to 5, you cut it off. This is not up to this 0, you cut it off when you want to plot. This is 6. You approximate this, you add it to 7, making 1. This is 1, it's not up to 5. So we are going to plot 1.00 against 1.54. So 1.00 is this. 1.54 is 1.4, is 1.6. So 1.54 will be in between 1.4 and 1.6. Each of these square is 1.2, is 0.2. So this one will be 1.42, 1.44, 1.46, 1.48, 1.54, 1.52, 1.54. Against 1. The next one is 0.5 against 1.43. This is 0.5. 0.5 will be between 0.4 and 0.6. 1, 2, 3, 4, 5. So it will be here against 1.43. This is 1.42, 1.44. So it will be somewhere here. 1, 2, 3, 4, 5. That's that. The next one is 0.33 against 1.33. This is 0.2, this is 0.4. 0.33 will be between them. 0.22, 24, 26, 28, 0.3, 0.32. So this 0.33 will be between this one and this one. So you trace it to that point to against 1.33. This is 1.2. 1, 2, 3, 4, 5. 1.33 is here. 1.33 to 1.32 will be here. 1.34 will be here. So in between these two squares. So 0.33. 1, 2, 3, 4, 5, 6. This one 0.3. 0.33 will be here. Now, after that, the next one is 0.25 against 1.25. 0.25 this is 0.2, this is 0.4. Each of the square is 0.2, so 0.02, 0.22, 0.24, 0.26. So this will be between 0.25 and 0.26. So 1, 2, 3. The third one against 1.25. This is 1.2, 1.22, 1.24, 1.26. So it will be here The next one is 0.2 against 1.18. This 0.2 is 1.1. This 1.2. So 1.1 to 1.1 for 1.16, 1.18, 1.3, 1.10, 1.1 to 1.1 for 1.16, 1.18. On 2, where is 2? Okay, this is 2. 1.18 will be here. 0.2 against 1.18. The last one is 0.18. I mean 0.17 against 1.11. 0.17. This is 0.2. This is 0. 0.1 will be here. 1, 2, 3, 4, 5. This is 0.1. 0.12, 0.14, 0.16. 0.18. Between the 8th and the 9th. So that's 0.17 against 1.11. This 1.1, 1.0 to 1.12. So it should be here. So now we are going to draw the hypotenuse. I'm going to draw it. This one will now give us this is the graph. These are the points. So it's called 1, 2, 3, and the remaining 2 are evenly distributed. Oh, one is evenly distributed. This one is on this side, deviated to that point. So with this one now, we can now calculate the slope. And now calculate our slope. This is vertical axis. Use this one for our vertical axis. And this for our horizontal axis. See a right angle triangle, 90 degrees. So this should be our y2, should be our y1, should be our x2, should be our x1. So we can now calculate the slope. Our y2 is 1.0. Our y1 is 0.2. our x2 is 2.0, our x1 is 1.2, 0.8 divided by 8, 10 minus 2, 8, 1 minus 1, this one will give us 1.0. So our intercept on the vertical axis is 1 minus this 0.0 minus 0.2 minus 0.4 minus 0.6 minus 0.8 minus 1.0 is minus 1.0. 1 over intercept. 1 over intercept is 1 over 1, which is 1.0. Now, after that, let's look at the precautions of this experiment. I noted and corrected 0 on the graduated scale of the meter bridge. I avoided parallax error. Then I ensure tight connection. B1. What is the main function of potentiometer? Potentiometer is a device to precisely measure potential difference. Resistivity. Define resistivity. Resistivity is the resistance per unit length of material of unit cross-sectional area. Thank you so much for watching this video up to this point. We are very grateful. Thank you.